Hi everybody, this is going to be our second video in our matrix unit, and today we're going to actually learn about, what a matrix is. A matrix is really just a rectangular array of numbers, and you're going to see it contained inside of brackets, which you see in the picture down here. And we're always going to describe the dimensions of a matrix by the number of rows followed by the number of columns that it has. So if you look at the one down below here, we have a matrix with 2 rows and 5 columns. So we're going to call that a 2 by 5 matrix, okay, 2 by 5. And typically our matrix will be equal to a capital letter, just to make it easier to refer to, because we're going to have multiple matrices that we're working with. Okay, matrices is the plural of matrix. So when we have multiple matrices, it's easier just to say like, hey, matrix A, matrix B, C, and so on. So each number that you see inside of the matrix here is what we call an element. Okay, and you can identify elements by its row and by its column. So down here, if I wanted to find A12, that means I want to find the element in row 1, column 2. Okay, well, row 1, column 2 would be here. So that means that element would be 1. Okay, and then A24 means I'm looking in row 2, column 4, which is going to be right here. So that's how you can identify elements within a matrix, and also the naming system that goes along with it. The little subscripts there are just telling you the row and the column that you're looking at. So we're going to look at doing some operations with matrices here. Adding and subtracting matrices is probably one of the easiest things that you can do, but there is a requirement. Okay, in order to add matrices together or subtract, they have to be the exact same size. They have to have the exact same dimensions, or we can't do it. Okay, and the reason for that is when I add or subtract 2 matrices, all we're doing is adding and subtracting the elements that are in the same position in each matrix. So it makes sense that we can't do it if they're different sizes, because there would be no corresponding elements to add or subtract. So let's look at example 1 here. We're doing A plus B, so I'm going to write this with the actual matrices here. So A is 16, 2, -9, and 8. Okay, and we're adding that with B, which is -4, -1, -3, -7. So to add these, all I'm going to do is I'm going to add elements that are in the same spot together. Okay, 16 plus -4 would give me 12. 2 plus -1 would give me 1. -9 plus -3 will give me -12. 8 plus -7 will give me 1. And that's it. Okay, that's all I have to do to add those matrices together. Okay, so let's look at example 2 now. We have B minus C. Okay, well, I notice a problem here. Okay, matrix B has dimensions of 2 by 2, right? There's 2 rows, there's 2 columns. But matrix C has 2 rows, there's 1 column. So their dimensions are different. They're not the same size. So we can't do B minus C. We're going to say that this is undefined because those matrices are different dimensions. Okay, so that's really important. They have to be the exact same size in order to add or subtract. The other operation we're going to look at is scalar multiplication. So scalar multiplication isn't multiplying 2 matrices together. It's just multiplying a single matrix by some scalar number. So if you look at our first example here, it says that matrix R is given here. It's a 2 by 3 matrix. And we want to find 5R. So that means that we're just trying to figure out, okay, what 5 times this matrix is. Well, to do that, all I have to do is multiply every element inside of my matrix by that scalar, okay, which is 5 in this case. So if I multiply by 5, my matrix is going to become negative 60, 40, 30, and then in my bottom row here, we're going to get negative 80, 20, and 95. So scalar multiplication is probably even easier than adding and subtracting matrices together. You're literally just multiplying each element inside of your matrix by that number. So let's look at another example here. Okay, example 2. This time we're multiplying by negative 4. So negative 4t, we can kind of save the step of writing it all out again. We just know that everything in that t matrix is going to get multiplied by negative 4. So we're going to get a negative 32, 0, negative 12, positive 8. And then in our second row, a positive 4, 16, 8, and a negative 36. All right, so hopefully that all makes sense. If you have questions, please let me know. That is it for this video. Adding, subtracting, scalar multiplication is pretty easy with matrices. Once we get to multiplication, that's when we're going to start having a lot more work to do. So I hope you enjoyed the video. Let me know if you have questions, and have a great rest of your day.